Hello everyone and welcome to Code with Beto. In this video we are going to learn how to create a Minesweeper game utilizing React Native and simple algorithms with JavaScript to create this functionality. This tutorial is going to be perfect for those who are starting with React Native, and for those who are not familiar with this game, it's just basically it's a game very famous that it used to come with Windows in the earliest versions. And you can see here this simple demo. If you search Minesweeper on Google, you're gonna find this little game. And the idea is that you have to find or uncover all the squares without finding any bombs. If you find a bomb, you're gonna lose, right? But you have numbers as well. And the idea is that if you find a number, it means that around this square or that square, you have, for example, if we have one there, it means that around this square it's one bomb. In that case, we have three, we have also a two. And as you can see, I hit a bomb right there, which means I lost right away, all right? Um, if I try it again, as you can see, we have a bomb, and around these bombs, we have like a counter, right? So if I hit in one of these squares, as you can see, that means that we have three bombs around this square. And if we find a zero, we are going to uncover everything until we find these numbers, right? Now, that tells us, or that tells the user that they have to be careful because there's a bomb, right? And I hit a bomb right there, it's game over. All right, so that's basically what we're gonna be building, guys. Of course, you can improve this by, adding a timer, changing some graphics, and there's many ways that I can think of that you can improve this game. But yeah, if you are starting with React Native, this is gonna be a perfect tutorial for you. And if you consider yourself that you are in level medium of React Native, this is gonna be a perfect tutorial for you, and it's gonna help you to improve your object-oriented programming skills. By the way, guys, if you want to get the source code for this tutorial or this project, you can go to codewithbeto.dev/projects, and you're gonna find in here the project. You cannot see it right away because I haven't put it here because I haven't finished the project, but as soon as I release this video, it's gonna be available on codewithbeto.dev, right? So now let's jump into this project, and let's start by creating a new React Native project by running the command npx react native init, and I'm gonna call this project Minesweeper. Notice that I'm already in this carpet called test. You can go to the folder that you want and create your project. Once it's ready, we can access this new folder and then start the development server by running yarn start. Of course, I need to open this on Visual Studio, so I'm gonna stop the server and open it on Visual Studio Code by running code dot, and then we can start the server by running yarn start. There we go. Now I'm here in Visual Studio and I already have my iOS simulator. And the first thing that I want to do is to build my application. So I'm gonna run the command npx react native run iOS. And this is going to take a bit. So while this is loading, we can start by creating a folders and start by creating some files that we are gonna need for this project. So the first thing that I'm gonna do is just create a folder, call it source, and this folder is gonna contain all the code for this application. I'm gonna start by creating another carpet or folder called components, and the first component that we're gonna create is gonna be called cell.js. This cell.js is gonna be a little square, each square, and each cell can be a bump, can be a zero, or can be a number greater than zero, right? If it has bumps around itself. So let's create cell, and the first thing that, well, after, before I start, adding some code inside this component, I'm gonna create another folder called utils. And inside this utils folder, we're gonna have a bunch of functions. And I want to extract these functions because if we keep these functions inside our components, it's gonna get pretty messy. So by splitting these in utils functions or functions of utility, we can keep the components a little bit cleaner. So the first function is going to be called create cell. And this is going to be a very simple function. It's just going to take the row and column of each cell, and it's going to return an object with the row and column. And this is a place in which we can, put all the features or all the components that we want to have each cell. For example, each cell can be a bomb, so that's gonna be a boolean, and our application is already finished building, so that's cool. And yeah, so I'm gonna start is bomb equal to false, and then we can have as many properties as you want. You can add whatever you want in here, but I think that the properties more important for each cell is gonna be if it's a bomb and the value of this cell, because remember, if it's close to a bomb, we need to increase this value. All right. Another important feature is that we need to know whenever each cell is flipped. So we're gonna have another variable called is flipped equal to false. And all the cells are gonna be initialized with these values, right? Now I'm gonna go to my app.js file and I'm gonna delete everything that we have here by default. And I'm gonna start by just exporting default this app component. And for now, let's return a simple React Native view. Notice that automatically it's imported up there from React Native. And inside this view, we can have cells, but for now, I'm gonna just leave it blank for now. And let's go back to our cell component and let's start working here. The first thing that I want to do is import React from React. And I like to import everything or asterisk as React from React because I think it's easier than use the hooks and all those components that we import from React, right? So let's start by exporting default this component cell, and because each cell is going to have all these properties, we know that we can have all these properties pass to this cell component as props, right? So I'm just gonna copy all this and we can simply delete these initializations and just put a comma after each property. And now we can play with these values inside this cell component. For now, let's return a view with nothing inside. Just I'm gonna hit save for now. Then we can start adding some values. Now that we have this cell component, we can go back to our app.js file and import this component. And after we hit save, we can see now this component in our application. But of course, we don't have anything, so we can't see anything at the moment. Let's start by adding a style so we know where is this cell, right, in the screen. So I'm gonna say style equal to styles.container, and I have to create this style because we don't have any styles in here. So I'm gonna say const styles equal to style sheet from React Native dot create, and this is gonna take an object of classes, and the first one is gonna be called container, right? So for now, let's say that the background color for each cell is going to be red, and we're going to give it a width of 30 pixels and a height of 30 pixels so we can see it on the screen. And if I hit save now, we can see that we have the cell up there. And if I copy a bunch of cells, we can see that we have all those cells in there. Perfect. So now that we have this component cell, we can start by changing the style, or we can simply create another component which is going to contain all the cells that we have in our game, right? So let's call this component board.js, and inside this board.js, we can start by importing everything as well from React. And this component is going to be the component that is going to be in charge of the state of the game. So we have to be a bit careful in here because we're going to have everything or all the logic of the game. So let's start by defining some variables that are going to help us to create the board, right? Let's start with a board size of 20 rows for 20 columns. And let's start with another variable, which is going to be the number of bumps that we want for each board. And let's start by saying that we want 20 for the board size and 10 bumps to start. So it's going to be pretty easy with 10 bumps, I think. And now that we have these variables defined, we can go ahead and create another function that is going to be a function that is going to help us to create the board. And a board is going to be just like a 2D matrix that is going to contain the information of each cell in each row and column, right? So let's call this utility function create board, and let's export this function and call it create board. This is going to be a pretty simple function. It's going to take just the board size or board width and board height and the number of bumps, so we can create this board. Of course, you can change these parameters if you want, guys. I'm just going to go ahead and say width, height, and bumps. And now that we have this information, we can create a 2D matrix. So I'm going to start by declaring a matrix and initialize it to be an empty array. And now let's just define what we're going to be doing here. We're going to have this array, right? And inside this array, we're going to have cells inside an array. So I can create a cell like this. I'm going to say x, x, x for each cell. And we're going to have a bunch of rows, right? So this is how the board is going to look. Let's say that instead of having an X here, this field or this cell is going to be a bump. So I'm going to change this X to be B. And now as soon as we put a bump, we need to change these values to be 1 because it means that these cells are close by 1 to a bump, right? So basically this is what we need to do when we create a board. So if we have another bump, we need to increase these values by 1 as well, because it means that we have 2 bumps close to these cells. Nice. Perfect. So I hope this makes a little bit of sense, guys. And let's start by adding this functionality down here. I'm going to start by creating a for loop, and we are going to iterate for each row. So I'm going to say let row equal to 0. And the row is going to be the height. So I'm going to say row less than width. I mean, at this point, this board is going to be a square. So it doesn't matter if we take the width or height for the row. And inside this for loop, we're going to need another for loop for the columns. And for each column, I'm going to change this to be height and the columns to be width, and col plus plus as well. Perfect. So now that we have these two for loops, we can start just pushing inside each row. So I'm going to declare another array that is going to be each row. And for each column, we can push. And remember that we have a function that is called create cell that is going to help us to push all the information that we want for each cell. So I'm gonna just call this function inside this push. Remember that this create cell is going to return an object with all the variables or all the features that we need inside each cell. So let's pass it the row and column for which we are iterating at this point. And after we finish to create this row, we can push this row inside the matrix, and we can do this n times, which means whatever we want to be the height of the board, right? So insert bumps. Now, after this, we need to insert bumps, right? And after inserting bumps, we need to increase the number for the neighbors of this cell, right? So I'm just gonna create these comments for now, and let's just return this matrix, and we're gonna come back to fix this or to add this functionality that we need. So at this point, we should be able to create a board. So let's start by exporting this board component. So I'm gonna say export default function board, and for now, let's return just a view. View from React Native. Notice that it's automatically imported up there. And let's start by creating the state of this game. So we could have a bunch of use state hooks here and a bunch of, for example, use effect that are going to help us to change the state of this game whenever the user presses a cell or whenever the user loses the game. We need to update the state, right? So a way to abstract all this logic from this component board could be creating or using a use reducer hook from React Native. And if you are not familiar with the use reducer hook, don't worry, I'm gonna try to explain it here. Or you can just follow up this tutorial and just try to figure out how it works. But the idea is that it's very similar to a use state, but this use reducer is gonna take a function reducer that is gonna help us to update the state of the game, but we can have this function outside this component, so we don't have to have a bunch of functions inside this component, because we are going to have like 3 or 4 functions, and this component can get very messy. So this is going to return the state, so I'm going to call this game state, and it's going to return a dispatch, which is going to allow us to update or make updates to the state, right? So the first parameter that use reducer takes, it's a reducer function, and I call it game reducer. Of course, I haven't created this function. We're gonna create it in a moment. And the second parameter is the initial state, and the initial state is gonna be an object which is going to have the board, and the board we are going to initialize it with the function create board. Remember that create board is going to take the width and height of the board and the number of bumps. So we can simply pass these variables that we already defined. And remember that this create board is going to return us the matrix. But now I'm realizing that I call row this array row, and it's interfering with the row of the for loop. So I'm going to rename it for new row. We have to be careful here to don't have the same variable name. All right, so now that we change this row for new row, this create board function should be working. And now we can change this semicolon for a comma. Perfect. Now, this is pretty much how the state is going to look inside this component. And now whenever we need to update this component, we can do it in another file, right? Or with our game reducer function. We could have as well more state in here. For example, the number of cells that we need to win, or we can have a variable Boolean that is gonna let us know when the user loses the game, or when the user finds a bump, or whatever you need for the state, you can add it inside this reducer, right? So now that we have this board, we can access to the game state.board, and we can start iterating over each cell so we can print the board on screen, right? So let's start by saying that we are going to iterate for each row. Remember that each row it's an array, and each row has cells. So let's start by saying that we're going to iterate for each row. Remember that .map returns or let us use the IDX for each, the index for each item that we are iterating. So the second parameter is going to be the index, and I call it row IDX. And now this component or this map can return a view, which is going to be a row, right? And remember that whenever we use map with React, we need to provide a key. So React knows which component or which row is which row whenever it needs to render this row. And now for each row, we can apply the same logic. We are gonna say row.map because remember that this is a row or an array. And inside these rows, we can now access to the cell or the cell information. So I'm gonna say cell and cell IDX because we're gonna need as well the IDX to provide it on each child. So here we can pass the cell, all the properties that we have in this cell. And if you don't remember, the properties that we have in each cell is the row, the column, is a bump or is flipped and all that, right? So now we can go back to the board, to the app.js file and print the board. But I have a minimum error here. And the error is that we haven't created the game reducer function. So let's go ahead and do that. Let's, and like I said before, we can abstract or extract this function from this component so we can have this board clean, right? So let's go ahead and create a new folder inside our source folder and call it reducers. And here we can have a bunch of reducers, but for this project, we're going to have just gamereducer.js. After we create this file, we can export this function, right? And the idea of a reducer is that we're going to call this function whenever we want to update the state of the game. So this function is going to take the previous state or the current state of the game and an action. And this action is going to have what we want to do with the state, right? So for example, when the user press a bump or when the user press a cell, we want to end the game or just flip the cell or open all the cells that we have with zeros, right? And all that information we're gonna need to pass in a type of action. So we need to define what type of action we want to do with the state. And we need to pass as well the row and the column because each time the user presses a cell, we need to let know that this reducer which cell we pressed, right? And we let the reducer function know by telling which row and which column is this cell, right? So now we can have a switch case with the type, and we're gonna have just one case for now, and the case is going to be handle cell. So notice that the switch is going to run depending on the type of the action that we want to do in this state, right? So now we can import this reducer function and pass it. And although it is not doing anything at the moment, we can see that the code is working. I just have this warning because I forgot to add the IDX, the cell IDX for each cell. And as you can see, we have a bunch of cells. We just need to add some style just to make it look good, right? But we have all the cells that we created by passing a board of 20 by 20, right? So remember that this view is going to be a row. So I'm going to create a styles here by saying styles from React Native.create. Remember that this is going to take an object of classes, and I'm going to create just one, call it row, with a flex direction row, because we want each row to have the items from left to right. So now we can add to this view this style.row and hit save. And there we go. We have 20 by 20. Now, this is looking bad, but if we go back to the cell component, we can start changing these styles. I'm gonna delete the background color and I'm gonna add a border width of 1 and a border color of gray for now. If I hit save now, we can see the grid. Now, at this point, I'm noticing that we have a bunch of cells, and I think we can fix this just by changing the variables that we provide to create the board at the beginning. But yeah, I'm gonna create another function, another class called container, because I want this to be center of the screen. But before I do that, I'm going to change the board size. Let's say 10 by 10, and we need to reload this to run the function again. And there we go. There's our board and it's looking better. So now let's try to center it on the screen. If I say on this container align item center, we see that it's now in center. And just to make sure what part of the screen we are taking, I'm gonna add a background color red, and I'm gonna take 100% of the height. And now that we have the 100% of the height, we can say justify content center, and the board is going to be in the middle of the screen. Now we can remove the background color, and let's keep working. I guess we can change again the board size if you want to add more. If you want to have a different width than height, if you don't want a square, you can have a rectangle. That's no problem. But yeah, let's go ahead and go to the cell component and add a text for each cell, and just for now print the row and column. And if I hit save now, we can see that we have 100 cells, and each one of these cells has the row and column, or you can call it X and Y coordinates. But the idea is that with this row and column, we're going to access or update the state, right? And if we check the value, it's going to be 0. Remember that we are initializing each cell to be a value of 0. And yeah, just for now, I guess I'm just going to put a bump just to see how the bumps are going to look in our cell. And as you can see, it's not aligned. It's on the upper left side. And in order to have these items aligned, we can say align content center and justify content center. Okay, instead of align content, it's align item center. There we go. That's what we want. And maybe we can make this text a little bigger. So I'm gonna add another style for this text, and I'm gonna say styles.text, right? Now we need to create this class down here. I'm gonna say font size of, I don't know, 22, for example. Let's hit save, and I think we can make these cells a little bit bigger. 40, I think it's too much. Let's change it to be maybe 35, could be better. Let's change the height to 35, hit save, and I think that's perfect for the board. Now we can go ahead and delete this bump, and for now, let's just print the value of each cell. Now, whenever we have a number, we can have a bunch of styles, guys. For example, if you have a 4, which means that around this cell you have 4 bumps, so you can add or change the color to be maybe red. But if you have just 1 around this cell, you can have the number to be green, for example, or yellow. But yeah, for now, I'm just going to add a font size of 22 and font weight of 80, so we can see a little better these numbers. And let's just leave it like that. Let's go back now to the create board, and now we can continue adding the logic that we need to insert the bumps, right? So now at this point we have the matrix, right, or the board. Now we need to insert into this board the number of bumps that the user wants or the developer wants, right? So let's create another function, and this function is going to be called insert bumps. And this function is going to take as a parameter the matrix or the board, whatever you want to call it, and the number of bumps, right? So let's take the matrix and the number of bumps. Remember that we are passing the number of bumps on the create board function. So now that we have this, we can define the height of and the width of the matrix, because the matrix can change. So we can just go ahead and say bumps to insert equal to bumps, right? Because this variable is going to change. We're going to have a loop that is going to run as long as we have bumps to insert. So let's do that in a while loop, right? I'm going to say bumps to insert. As long as bumps to insert is greater than 0, we can insert bumps, right? But now, how can we get a random position on this matrix? We can simply grab the width and height, like I said before, and grab a number between 0 and the height and 0 and the width, and then insert a bump in that position. So I'm gonna say row equal to, and we don't want decimals, right? So I'm gonna say math floor, and now we can say math.random. This is going to generate a random number, but this is gonna be a decimal number. So we need to multiply this by the height of the matrix. So I'm gonna say matrix.length, and we can do pretty much the same thing for the column. And basically, guys, if you don't understand this line, basically the idea is that you are going to grab a random number between 0 and the height of the matrix, and then from 0 and the width of the matrix. So I'm gonna say column, and to grab the width, we can say matrix at the position 0, because remember that it can be a rectangle, so it could be different height and width. So you have to be careful here. But for this tutorial, we're gonna be using a square, but it's never bad just to have support for rectangular matrices. So now we can just check if the matrix at the position random that we just generated is not a bump. Remember that we have all this information inside each cell. So if it's not a bump, dot is bump. If it's not a bump, we can go ahead and insert a bump. How can we do that? We can simply grab this position and say is bump equal to true. That's super easy, and that's how it works. And yeah, after we have this update in this cell, we are going to keep doing this until we have bumps to insert. Once we insert this bump, we need to decrease the bumps to insert by 1, so we don't have an infinite loop in here. And that's pretty much all we need to do for this function. So now we can call it after we create the matrix. We pass the matrix, and then we pass the number of bumps. Remember that we are receiving this number of bumps inside this function as a parameter. And let's go ahead and just go to the cell component, and for each cell we can print if it's a bump, right? So if it's a bump, we can say if it's bump, we can print a bump. Otherwise, we can just have the value, right? Let's hit save and reload the application just to see if this is working. And as you can see, guys, we have here 10 bumps, which is the number of bumps that we initialize this function. And it seems like it's working. And if I reload, we have a different positions for each bump. We can, change this to be 10 again, or 20, whatever bumps you want. Now we need to increase the numbers, right? So as you can see here, around this bump, we need to grab all these neighbors and increase the value of each neighbor. So the idea for this algorithm or for this function is just to iterate for each cell in the matrix, and then if we find a bump, we are going to increase all the neighbors by 1. And then if we find another bump right next to this bump, we are gonna do the same. So that means that if we increase we can increase a cell like at most 10 times if it has 10 bumps around itself, right? So I'm gonna call this function increase nums. And the idea, like I said, just it's gonna be just iterating. Whenever we find a bump, we're gonna graph all the neighbors, iterate for each neighbor, and increase its counter or its value, right? And after we increase the value, we're going to continue. And remember that we can increase a cell multiple times if we have a bunch of bumps around this cell, right? So pretty much same idea. We need two for loops to iterate for this matrix for each cell. So I'm gonna say row less than matrix of length, and then let column equal to 0. We're gonna start at 0, less than matrix at the position row. Remember again here, it could be that this is not a square matrix, so we can just simply access to matrix at the position row, which is gonna give us the width of the rectangular matrix in that case, uh, and dot length, right? So that's gonna take from left to right, and then we can increase this column by 1 each time we iterate over each cell. So now here we can simply check if matrix at this position in which we are iterating, if this is a bump, we need to grab the neighbors, right? We are going to need a helper function to grab the neighbors. So I'm gonna just say const neighbors equal to get neighbors. I'm gonna call this function get neighbors. Of course, I haven't created. We're gonna need to create it in a moment. But yeah, this function is gonna take the row and the column of where we find this bomb, right? So we pass this row and this column, and as well we're gonna need the matrix to get the neighbors in this function. So after we get the neighbors, this is gonna be an array of coordinates, row and column, or you can say x and y, and we are going to iterate for each of these coordinates or neighbors. And for each neighbor, we are going to have two parameters, which is the row and column, and I'm going to destructure it like this. And now we can access the matrix at this position of the neighbor and have its value increased by 1. So we can say dot value plus equal 1. Perfect. This is looking good. I think that's all we need to do. But of course, remember that we are going to keep increasing its value if we have another bump. So we can just increase the value by 1. So we don't need to do any validations in here. Just increase the value by 1 each time. And to get the neighbors, I already went ahead and create this function get neighbors, which is going to take the row and column and the matrix. And you can pause the video at this point, guys, but the main idea is that we are validating that we are not out of the bounds of the matrix. So I start by defining the height and width of the matrix. Then we have a new array in which we are going to push all the neighbors that we found. And for example, let's imagine that we are in the row 0 and the column 0, and we want to grab all the neighbors. Of course, we are not going to have neighbors to the top and to the left because we are at the row 0 and column 0. So this is what this function is validating. If we subtract 1 from the row and it's greater or equal to 0, which means we are inside the bounds of the matrix, we want to push the neighbor. Otherwise, we don't want to do anything. So that's why we have these if statements, and it's basically the same for each one of these lines of code. Like I said, you can pause the video. And if we have a valid neighbor, notice that we are pushing an array of size of 2, which is a row and column. And after we graph all the neighbors that we can for each bump that we find, we simply return the neighbors. So this is a pretty simple function, although it's pretty, I would say, difficult to implement because you have to, you know, be adding one and subtracting one and all that. But yeah, after we have this function, we simply grab the neighbors, and for each neighbor, we are going to increase the value, right? Super easy. Now we can call this function after we insert the bumps, because at this point we have bumps in the matrix. We increase the bumps, we pass the matrix, and now if we reload this, we should have values around each bump. And as you can see, it's working. We have 1, 1, 1 for the first one, and then in this case that we have 8, 3, it means that around this cell, it's that there are 3 bumps. So it's working fine, this algorithm. And of course, if you didn't get it, guys, I encourage you to pause the video and try to implement this function by yourself, or try to just understand how this is working. But yeah, this is a pretty simple function. Now that we have this, we can start adding functionality into our cell component. The first thing that I'm going to do is just change this view to be a pressable, which can give us the onPress action. Whenever the user press a cell, we want to flip it, right? So the first thing that I'm going to check here is that if it's flipped already. And so we can say if it's flipped, then we can validate if we are going to render a bump or its value. And if I hit save now, of course, this is not going to work because we have 2 statements here. So I'm going to put all these statements inside a parenthesis. So now it's looking like this. If it's flipped, now we can validate if it's a bump, right? If it's a bump, we're going to print the bump. Otherwise, we're going to print the value. Now, because neither cell it's flipped at this point, we can just change the background color of each cell just to give that user experience. So I want to say background color light blue, and let's add this style to the pressable container. So I'm going to add an array of styles, and then we can have a comma here, and then styles.flipped, right? If I hit save now, we're going to add this style, but of course we just want to add this style if the cell is flipped. So we can validate here if it's flipped, we can say styles.flipped. Otherwise, if it's not flipped, we want to show the bump or the value, right? So we can say if it's not flipped, we're gonna have the is flipped style, right? Perfect. So now it's working. Now we can add the functionality whenever we press the cell to flip it. So we're gonna need a handler for that, right? So I'm gonna say handle press, and we're gonna pass this function as a parameter as well. And this function, guys, is going to take the row and the column, remember? So I can say handle press in here, but because we're gonna pass parameters to this function, we need to have inside this handle press another function, and then we can open parentheses in here and pass the current row and the current column that has each cell. So if I hit save now, nothing is going to happen, but if we try to press each cell, we're gonna get this error because we are not passing this function whenever we are iterating on these cells. So let's go back to the board component, and inside this board component, we can add the handle cell function. So let's create this function in here. And this is the beauty of having a reducer, or the beauty of using a reducer, because now we can simply say this batch. Remember that we want to change the state at this point. We want to flip a card. So we can call this batch, and we can simply say what we want to do with this state. In this case, we're going to say the type of the action that we want to do. And if we go back to the game reducer, we know that we have just one case. So we can simply copy this handle cell type and paste it here. So this is what we want to do, right? We want to handle cell. But now we need to let know the reducer which cell we want to handle. And we know that by passing the row and the column of each cell. So now that we have this, we can simply grab this row and column from the action inside the game reducer and change the logic outside of this component board. And this is all the logic that we need inside this board component. And now just we need to just pass the handle press in here as property for each cell. And that's basically it. So I'm gonna put an alert here just to see if it's working. If I press a cell, we can see that we have this alert, but we get this error because we haven't added any functionality or any logic inside the game reducer function. But yeah, this is all we need inside this board. So as you can see, it's pretty clean, this component. So now we can go to the reducer and handle this cell. So we already are destructuring the row and column. So we can say, or we can validate if the state.board at this position that we are receiving is a bomb. If it is a bomb, it means that the user has lost, right? So we can simply end the game. But whenever the user loses, what I want to do is to flip all the cells so the user can see where the bombs were. And so yeah, to just flip everything and let the user know that they have lost, right? So I'm gonna have a function that is gonna be called flipped all, and it's gonna take a matrix, and we are going to return another matrix with all the cells flipped, right? But we don't have this function at the moment, so I'm just gonna go ahead and comment this and just return this state, right? We could have another variables to let the user know that the game is over, but for now, just leave it like that. Let's just try to focus on the next state. So we're gonna have an else if in here, and we can pretty much copy this. We are going to check again in the state.board. Remember that the state is an object that has a board property. Now we are going to check if the value is 0. It means that we want to expand all the cells or flip all the cells that have zeros, right? So let's go back to this example. As you can see here, I pressed a 0. Of course, we can see the zeros, but the idea is that we need to open all this part of the board until we find numbers, right? Which means that there's bombs right after these numbers. But we don't want to open everything or flip each cell. We just want to flip until we find numbers, right? So let's just close this game. And look, we want to do exactly the same. So for example, here it's obvious that there's a bomb because we have a bunch of ones, and yeah. So the user knows how many bombs there are close, right, to these cells. So we're going to need another function that is going to help us to expand. So I'm going to just put a comment that is expand, and for now, let's just return whatever the state has whenever we have this action. And finally, if it's not a bomb and its value is 0, it's not 0, it means that its value is greater than 0, right? So we can just simply have an else in here. And whenever we hit a number, the thing that we want to do is just flip this cell. So we can just return whatever the state has plus the board. The board is the property that we want to change. So we're going to have a function called flipped cell. Now guys, remember that when we are updating state in React, we cannot access the variable and changing directly. We need to replace the old state with a new state, right? So this function flip cell is going to take the old state, which is the matrix, and the position of the row and column of this cell that we need to flip, right? So this is the simplest function that we need to create. So let's start by adding this functionality. So let's go down here and create a flipped cell function. But before I do that, this switch case, guys, whenever we finish this case, we can have a default case as well. For example, if the programmer tries to handle a state or a type for this reducer that we don't have, we can simply print in the console error action unknown. And this is a good practice, so make sure you add it into your code so the programmer knows whenever he's trying to do an action that we cannot handle, right? So now let's flip cell. Let's create this function. Remember that we are gonna get the board as a parameter. And remember that we need to replace the old state. So this function needs to return a new matrix. So I'm gonna say const new board equal to board.slice. And for those who don't know, slice creates a copy of this array of arrays, which is a board, right? So we create this copy by saying board.slice, and now we can apply all the logic that we want inside this new board cell. So let's access the cell that we want to change by saying const cell equal to new board at the position row and column, and then we can change this cell by copying all the state that we had in this cell, but now we want to flip this cell, right? So we can say is flipped equal to true. Perfect. Now we can replace this cell in the new board by saying new board at the position row and column equal to new cell. Basically, we are replacing the object that we had in this position. And after we do that, we can simply return the new board. So I'm gonna say return new board, and now we can call this function in here, and this should cause an update in this state, which is going to cause a re-render in our application. And now if I hit save, we can see that we are flipping all the numbers or all the cells that we are pressing, because I put this function inside each if statement. But of course, whenever we find a 0, we want to expand, and whenever we find a bump, we want to finish the game. So let's minimize this function and let's create another function which is gonna be called expand, and this function is going to help us to expand. Now, if you are familiar with algorithms and data structures, it's gonna be super easy for you to integrate this, to create this function. The idea is that we are going to copy the board as well, and we're gonna create a DFS algorithm, or depth first search algorithm, or breadth first search. You can use whatever you want, but if you are not familiar with these algorithms, don't worry. I'm gonna try to explain it in here. But the idea is that if we find a 0, we want to grab the neighbors again. And for each neighbor, if we have a 0, we want to grab its neighbors again. And we want to do that until we find a number, right? So we want to keep expanding until we find a number like this. So how can we do that in code? We can use a DFS algorithm. And we can do this in different ways. I'm gonna do the breadth first search approach, and the idea is that we're gonna have a stack in which we are gonna push all the neighbors that we find that we need to flip, and for each neighbor we need to get its neighbors, right, until we find a number. So I'm gonna say, while we have elements in this stack, while stack.length is greater than 0, I'm going to pop from the stack the current row and the current column. And remember that we have this function that can help us to get the neighbors. So I'm just gonna import it like this, get neighbors. I'm gonna pass the row and the column of the current cell that we are iterating and the board, right? The new board. Remember that these neighbors, this is gonna return us an array of neighbors. So now we can iterate for each neighbor, right? We can destructure this neighbor. We can grab the row and column for each neighbor like this by saying equal to neighbor. And now here we can do a very important thing, because if we don't do this if statement, we are going to end up with all the board flipped. And here we need to check if this is already flipped. So it means that we already visit this cell, so we can continue. We can just ignore this. We don't want to do anything because this cell is already flipped. So just continue. Otherwise, we can check if this cell is not a bomb, because we don't want to uncover the bombs, so we need to validate this thing. And if it's not a bomb, we can simply go ahead and say new board at the current position dot is flipped equal to true, right? We need to flip it until we find a number. Now we need to make another important validation here. If we find a number, we want to stop the algorithm. Otherwise, we want to push this cell. If we find a 0, we want to push this cell to the stack so we can grab its neighbors of the neighbor and continue with this algorithm and continue flipping cells. But if the current position of this cell dot value is greater than 0, which means that we find a number, we want to stop it, right? So before we push to the stack, we can validate this and simply return or continue. So I'm gonna say continue, which means that if we find a number, we are going to flip it, but we are not going to grab its neighbors, so we can stop. Otherwise, if we find a 0, we are going to add it to the stack, which means that we are going to end up with all the zeros flipped. Now, finally, we can return the new matrix, and inside of this expand if statement, we can change this function, and it's taking the same parameters. So if I reload, it's working because I find a number, which means that we want to flip this cell. But if we hit a 0, we're going to expand the board all the way until we find just numbers. Perfect. And it seems that it's working. As you can see here, I hit another 0 and I'm pretty much done with the algorithm. And here we can see that we have a bomb. It's pretty obvious because all the numbers around this bomb are 1s or 2s or 4s. And perfect. So now we just need to handle when the user loses. And when the user loses, we just want to flip everything and say game over, right? Like you lose, game over, and flipped everything. And this flipped everything should be pretty easy. Of course, guys, we can have another variable inside this game state of our reducer, or we can just simply have another some sort of validation. And there's many ways that you can implement these, guys. I encourage you to implement it the way that you want to do it. But yeah, we need another function that is gonna be called flipped all. Function flip all, and let's just pass the board, right? Because we don't care in which cell or which position we find the bomb. We just need to flipped all, so we just need the matrix. But of course we need to create a copy, so I'm gonna say board.slice, and then we can iterate for each cell and change its variable it's flipped equal to true, right? So we're gonna need 2 extra for loops to iterate for each cell. So let's say row equal to 0, row less than board.length, and then we can do pretty much the same thing for the column. But remember that we are supporting rectangular matrices, so we can say new board at the position row.length, which is the width of the matrix, And now we can simply change the cell. I'm going to abstract the cell by saying const cell equal to new cell at this position. Then we can say new cell is gonna be equal to whatever we had in this cell, but we're gonna say is flipped equal to true. Now we can replace this cell in the new board for the new cell. So I'm gonna copy the new board at this position and I'm gonna say equal to new cell. Perfect. Now that's pretty much all we need to do. We can simply return the new board and just call it whenever the user loses the game. So let's uncomment this, hit save, and let's try to lose. If we lose, we are going to flip all, and as you can see, it's working. Perfect. Now we are changing this variable as well in here, and we can use this variable to render some UI in the board. So we can add in here a text, for example, and of course I need to import text from React Native. So let's do that up here, hit save, we have our text in there. So whenever we are playing, we can say Minesweeper, and whenever we lose, we can say game over. But this text is looking pretty lame, so I'm gonna add some styles in here. I'm gonna say text, font weight, let's say 900, font size, let's say 32, hit save. Let's go to this text and add this style. Styles.text. Hit save, and there we go. Our text is looking good. Perfect. So now remember that we are using this variable, or we have access to this variable inside the game state. So I'm gonna say if it's game over, so game state dot is game over. If this is true, we want to say game over. Otherwise, we want to have Minesweeper, right? Of course, you can have whatever you want, guys. And let's close these braces. Perfect. Now let's lose the game just to see if the text updates, and it updates. Perfect. Let's pretty much lose again, and perfect. Now, I mean, it seems that this is working perfectly, guys. And just to, make a recap, we are using this dispatch to handle the state outside this component, right? Which allow us to have this board component super clean. Basically, we only have one variable in here and one function, and we could have this dispatch handle press inside the cell. But of course, I mean, having it up here, it's not that bad. It's just 3 lines of code. We pass a row, we pass a column, we call the dispatch function, we handle the cell, and we update the state, which means that whenever we update this state, we're going to generate a re-render, and we're going to update the UI. Nice. So basically, guys, that's all I wanted to show you. Of course, we can change the board size. You can let the user change the size. For example, if we add 40 bombs, and if we try to play, I hit a 0 right there. But of course, I'm going to lose right away. But yeah, you can change these variables. You can let the user change these variables. Remember, guys, that this code is going to be available at codewithbeto.dev if you want to check it out. And if you want to keep adding a bunch of variables in here, you can do it, and you can change all this logic inside the game reducer function. You can add a bunch of types of actions that you want to handle. And yeah, guys, that's pretty much all I wanted to show you. Don't forget to hit the like button if you like this video. Let me know in the comments if you have any questions, if you need me to create another tutorial. But yeah, I hope you like this video. I hope you learned something new. and I'll see you in the next one. Don't forget to subscribe. Bye.